get that in playback. Okay, so one last problem for celestial mechanics. We're going to be talking about the surface gravity. At any rate, I'm going to end up finding the surface gravity for the moon, because you can find where I've got in notes surface gravity for Earth. But I just thought this one would be a bit more interesting an example. So what is the surface gravity on the moon? And then we'll use that surface gravity to talk about what your weight would be on the moon as well. So surface gravity is given by this equation. Little g surface gravity equals big G m over r squared. M is again the mass of the planet. R is the planetary radius, just like we were doing with escape velocity. At any rate, here I've got my substitution. I've substituted in for capital G, the constant of universal gravitation, the mass of the moon, and then the radius, the planetary radius of the moon. And since that one was squared, you can see that I've written it out twice, because I had to do the unit conversions twice in order to get the units to work out correctly. But at any rate, kilograms cancels here, kilometers and kilometers would cancel 1, 2 over here, and meters would cancel 1, 2 here, leaving me with units of meters per second squared, which are of course the units of surface gravity. Surface gravity, as a look at its units indicate, is actually an acceleration rate. If I were to drop a ball on the surface of the moon, of course this drawing is not to scale, but if I were, one of the first things I would notice about that I'm not on Earth is that the ball would fall much slower. And so this rate actually indicates that at a rate of 1.62 instead of at a rate of 9.8. The second half of this is where we compare surface gravities to give your weight on the moon. So we have this formula: weight on Earth times the surface gravity on the planet divided by the surface gravity of Earth. Earth's surface gravity is a constant. It's 9.8 meters per second squared. And so what we do is, let's say I weigh 200 pounds. Then we multiply that by the ratio of the surface gravity. I weigh 200 pounds on Earth. On the moon, I would weigh 33 pounds at any rate. And so that's kind of interesting. So the first thing is, if we were to put you on the moon, it would be a big noticeable difference, because you would not weigh nearly the same. And so it would be strange to wake up on the moon. You would notice it immediately.